Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And good afternoon, everyone. How's everyone this afternoon?
Good. Waalaikumsalam.
Good.
Okay.
Waalaikumsalam. Fine.
All right. Okay. I hope that everyone has submitted their assignment 2 last week. Last Friday. I have not yet downloaded all the assignment questions. Because I am still in the midst of marking your test paper. I have not yet finished marking, but I only have like a few more scripts. So hopefully by this week I can finish marking, and perhaps next week maybe I can give some feedback regarding the test paper. Okay, just to inform you that assignment 3 is coming. Okay, so I think we are going to upload assignment 3 by this week, perhaps by Friday. Okay, so once I got the questions from the coordinator, so I'm going to upload. And once I've uploaded the assignment 3, I will inform you all through WhatsApp as usual. Okay, and that will be our last assignment. Okay, assignment 3 for the course. Okay, so you are now in week 12. All right, so you have another perhaps 3 weeks more to go. Okay, before your end of semester. Okay, before your final exam. Do you know when is your final exam for this course?
Yeah, actually, madam, I wanted to ask that. I checked the SMP. Is it? I don't find anything. Haven't updated anything. Is it?
I think they have not yet released. Okay, they have not yet released the timetable for final exam. Okay, but as far as our subject is concerned, all right, tentatively it will be on, if I'm not mistaken, let me just check. If I'm not mistaken, our paper is on the first day of the exam. Hold on, for 28th of January. Okay, for this paper, for this course, your technical maths, it will be on the 28th of January, in the morning, 9 o'clock in the morning. Okay, but this is I hope that this is already confirmed. But anyway, I think you wait until they publish the final exam schedule for all courses. All right. But I think as far as I'm concerned, I think this one is already like confirmed for our paper. Okay, it will be on the first day, on the 28th of January. So that means you have like 1 more month. Okay, exactly like 1 more month. Okay, before your final exam, right? And I will talk about final exam towards the end of semester. But anyway, I think final exam consists of almost all chapters except for maybe chapter 1, if I'm not mistaken. Okay, all right. Okay, it's okay. I will talk about final exam later. All right, towards the end of semester. But what we have to do now is to actually proceed with our lecture. Okay, we still have a bit more. All right, sections to finish up for this chapter 4. All right, and I hope that everyone also is going to catch up with all the questions, okay, tutorial questions in the book, especially, even though you are going to have your assignment 3, okay, but don't forget about questions in the book as well, because during tutorial we are going to discuss. And for your tutorial this Thursday, what again, like I mentioned last week, what I'm planning to do is for the first 1 hour, maybe I'll just discuss the application of trigonometry. So I'm going to select some of the questions, okay, from applications of trigonometry. And then for the next 1 hour, maybe we can actually take a look at some of the okay, Sharvin, can you hear me? Sharvin Rao? All right, okay. And the next 1 hour during the tutorial for this week, I'm going to discuss perhaps some of the chapter 4 questions. So perhaps you have you can start doing some questions in complex number. Okay, so any other questions to ask before we start our lesson today? Let me just share the content. Any questions to ask? Okay, now just to recap, okay, whatever that you have learned last week, we talked about polar coordinates. Okay, we talked about polar coordinate last week, if you remember. All right, the difference between rectangular and polar, the similarities, okay, between rectangular and polar coordinate axis. All right, and today what we are going to look at also actually another coordinate system, okay, for complex number. Okay, but anyway, when it comes to like a rectangular, you'll be talking about xy, okay, xy coordinates, and then when it comes to polar, it will be about r and theta. Okay, and then I've shown you last week also regarding the how do we actually plot. Okay, we plot polar coordinates. All right, on our paper. All right, without any like polar grid given. Okay, and the most important stuff actually last week is about this relationship between polar and rectangular, because you are going to see this again today. Okay, so you are going to see again all this relationship, okay, as we talk about complex number in polar form. Okay, so again, as I mentioned, that this formula, okay, it is actually is good to remember by heart. All right, because you'll be looking at this one again, you'll be using this actually again, all right, for the rest of the chapter. And if you have forgotten, if it somehow you forgot, okay, about this formula, you can always fall back on this diagram, okay, to come up with the relationship, okay, between rectangular and polar. Okay, all right, and then we have actually uh, we have done also some questions, some example last week. All right, the conversion between polar and rectangular. All right, so things like that. So basically, that's what we talked about last week. All right. So today, what we are going to do is actually we are going to continue. All right, which is talking about complex number in polar form. Okay, or polar form of a complex number, as well as what we call Argand diagram. So basically, Argand diagram is actually is another coordinate system, okay, when it comes to sketching a complex number. Okay, but Argand diagram is actually, it will be very similar to both rectangular as well as polar. All right, because again we are going to talk about complex number in polar form. So when it comes to polar form, you'll be referring to two parameters, all right, or two variables, okay, namely the r, okay, r, which is the distance, okay, from the origin or from the pole, all right, to the point, that is r, as well as theta. Theta is basically is the angle that is made by the polar axis to the what we call the ray, okay, the line. Okay, and when we talk about complex number in polar form, we will actually basically referring in terms of this type of standard form of a complex number. Okay, so most of the time you will see that textbook will always they somehow they prefer this notation z, okay, as a complex number. All right, and in terms of the standard form, okay, we'll be referring to in terms of x plus yi. Okay, previously we talked about standard form of a complex number in the form of a plus bi. Okay, so previously we said that a plus bi is a standard form of a complex number. Okay, standard form of a complex number. So then but once we talk about complex number in polar form, we will actually referring to this type of expression, okay, which is in the form of x plus yi. Why? Because later on you will see that when we want to convert to polar, okay, from rectangular. So basically rectangular is actually we are using x and y coordinate. Okay, so that's why then it will be perhaps much easier if we are looking at our standard form of a complex number in terms of x plus yi. So basically it's the same, it's the same as a plus bi. That means x is actually is the same as a, y is the same as the b. Okay, it is just that when we talk about a complex number in this form, which is x plus yi, then you will see that, how do we actually derive, okay, from rectangular form to polar form. Okay, before we look at in terms of conversion, okay, from rectangular to polar in terms of complex number, okay, we will actually talk about what we call Argand diagram. So Argand diagram basically is the same as, okay, this is the word Argand diagram. So Argand diagram, this is actually basically is the coordinate, some sort like a coordinate system, okay, coordinate system for a complex number, all right. When we want to graph a complex number, we will graph it in what we call Argand diagram. Okay, however, Argand diagram doesn't have any like a special coordinate system in such a way like previously polar, you remember I showed you the grid, okay, it's in a circle, okay, or we have like rectangular grid for rectangular coordinate system. Basically, Argand diagram, it will be similar to rectangular, okay, it's similar to rectangular. All right, in which you see that here it mentioned that the x-axis is called the real axis, y-axis is called the imaginary axis. So basically, when you draw, all right, if you want to draw your complex number, you still draw like your xy axis, okay, all right, still the xy axis. However, this x-axis, all right, we will label it as real axis, and the y-axis here we will label it as imaginary axis. So imaginary axis will actually follow your y-axis, okay, which is your vertical straight line, and this vertical straight line also goes down like that, okay, it can actually go down. Okay, real axis also, it can be going this way as well as going to be this way. And similar to rectangular, all right, similar to rectangular coordinate system also for Argand diagram, all right, you have in the middle is the origin, okay, which is 0, okay, the middle is like the origin which is 0, and x-axis is the one that you will actually plot, okay, or you look at in terms of your real number, because remember this x is actually is a real number or real part. So real part is going this way, and then this yi is the imaginary part. So imaginary part will be the y-axis here. So when you want to plot, okay, when you want to plot any complex number on Argand diagram. So it will actually be the same plot as you plot your rectangular coordinate axis, except for when it comes to rectangular coordinate, basically it's a point. Okay, it's a point on your xy plane or xy coordinate axis, but for complex number, basically it's like a line. Okay, it's a line. Okay, so I will show you later on, okay, after this. Okay, and you will see also that when you sketch your complex number, okay, this is the complex number actually, this is the one that I mentioned, a line. So this is actually is the complex number, the x plus yi is represented by a line. Okay, so when you have a line, basically you can talk about what we call the distance from this origin to this point. So this is actually is what we call the magnitude or modulus, all right, which can be represented by this, okay, which can be represented by this, all right, because this is the notation of modulus, all right, or magnitude. So it can be represented by this, which is a square root of x squared plus y squared. So if you look at this expression here, square root of x squared plus y squared, this is actually is the same as your r, isn't it? It's the same as r in polar form, okay, this is r, okay, so the magnitude is actually the same as the r, okay. All right. Okay. How do you plot? Okay. Now, how to plot complex number? Okay. I'll give you an example. Okay. If you want to plot, okay, example. Okay, you want to plot let's say 2 plus 3i. Okay. So plot this. Plot 2 plus 3i. So basically, this is actually is a complex number. So when you want to plot, just draw your x like your xy axis also. Okay. So you draw like your these two axes. Okay. It's just that when you label your x-axis, you label it as real axis, and your y-axis you will label it as your imaginary. Okay, imaginary axis. So when you want to plot for 2 plus 3i, so it's actually is similar to coordinate 2, 3. Okay, it's a similar to coordinate 2, 3. However, 2, 3 is only a point in rectangular. But for complex number, it's actually is a line. Okay, but the concept is actually is the same. All right, which means that you start from the middle point, which is the origin. Okay, so with the 2 here, that means it's positive 2 for the real part. So if it's a positive real part, from the origin, you go to the right 2 units, and then positive imaginary part, all right? So that means you go up 3 units. So actually it's the same thing. So assuming that 1, 2, 3, okay, so this is a point. So basically you just draw a straight line. So this is your complex number 2 plus 3i. Right? If it is a rectangular coordinate, your xy, so somewhere here, like here, maybe that point, okay, it's just a point, 2, 3. Okay, so you have like that, so you have like that. Okay, so it's a point in rectangular. But when it comes to when it comes to complex number, you have like a line. So when you have a line here, all right, that means later on, when we talk about polar form of a complex number or complex number in polar form, all right, so you'll be talking about the r and theta again. There's a r and theta. So basically, r is actually is this distance here, from here to here. Theta is actually is this angle. Okay, all right. Okay, so perhaps another example. Okay, another example to plot. Okay, maybe another example. Okay, let's say you want to plot um, maybe minus 1 minus 4i, for example. Okay, minus. So again, you just label your real axis and your imaginary axis. So you're going to plot like you plot rectangular coordinate. Okay, so minus 1 means that from the origin here, you go 1 unit to the left. Okay, and then with the minus 4, that means you go down 4 units. So assuming 1, 2, 3, 4. So you have a point there. Okay, and then you just need to like draw straight line like that. Okay, so that is your minus 1 minus 4i. So that is the complex number. Okay, all right. So basically that's how you plot. Okay, so if let's say I ask you to plot for example uh, plot minus 5i. Okay, minus 5i. So basically again real, okay, real axis and imaginary, okay, imaginary axis. Okay, so you don't have any real part, so that means from the origin there, so you just need to go down 5 unit, 1, 2, 3, 4, 5. So basically that is your minus 5i. If let's say you don't have imaginary part, for example okay, plot just this is in terms of complex number. This is like 4 plus 0. Okay, this is like 4 plus 0i. Just plot 4. All right. So that means it is on the real axis. Okay. So if it is in complex number, okay, that means you don't have any imaginary. Okay. So that means it means that your plot is actually is from here going that way, right? So this is 4. 4 plus 0i. This is what it means. So that means this is 4 units, something like that. All right. Okay. So this is how we plot. Okay. So now let's move on to what we call a polar form of a complex number or complex number in polar form. Okay. If you look at here, all right, you still have this. Okay. Remember, this is the formula. It's actually it's a relationship, all right, between your polar and rectangular. Actually you have one more here, which is your r. Another formula is actually is the r, which is the square root of x squared plus y squared. So basically you have your x equals r cosine theta, you have your y equal r sine theta, okay, and then you have your tangent theta equals y over x, as well as this formula r equals square root of x square plus y square. So this is actually they are gotten from the triangle previously, okay, the one that I've shown you just now or last week, okay, the relationship between polar and rectangular. Okay, so with this relationship, okay, so back to our rectangular form of a complex number. Rectangular form, okay, is in the form of x plus yi, or in other words, z represent complex number. So z equals x plus yi. So this is a rectangular form, okay, of a complex number, or is a standard form in terms of rectangular form, okay, of a complex number. So when we want to convert, okay, to a polar form from rectangular to polar, so basically we just need to change our x and y, all right, in terms of here, right? So which means, all right, this x, all right, this x is actually is this x, okay, this y is this y. So when you replace your x by r cos theta, so this is how you write it, okay, you replace x by r cosine theta, so plus, and then you have your y here, you replace by r sine theta, and then you still have your I there. Okay, so basically this is your polar form of a complex number. Okay, complex number in polar form. Okay, it is just that when we open up the bracket, okay, we can actually factorize our 1r. Okay, if you do not want to repeat, okay, writing as like r cosine theta plus r sine theta I, so we can just factor, all right, r 1r outside, and then in a bracket, then only you have your cosine theta plus, okay, we will write I in front of sine. Why? Because just to avoid confusion, all right, if we write like this, r sine theta I, so that can be like a confusion. Okay, it can be a confusing statement, because then you may think that, you know, this I actually is actually belong to theta. It's like together belongs to sine, like sine theta I. That's the confusion. All right, because in fact I is just a multiplication between r times sine theta times I. So this is actually is a multiplication. Okay, so to avoid being thought that this I belongs to theta or belongs to sine, so that's when we will write I in front. Okay, we will normally will write I in front of sine, so that can be that's when you will actually avoid having a confusion. Then only you can see, if you write like this, you will see that I is actually is a multiplication. It's a product. It's a product. I and sine theta is actually it's a product form. It's not like sine theta I like that. Okay. So normally this is how we write. Okay. We will write I in front of sine theta. Okay. And there is another notation that you might see. All right. Is actually using something like this in the book. Okay. In your module, you have this R and then CIS theta. Basically this is like a shortcut, it's a short form. Okay, C stands for cosine, I is the imaginary I, okay, complex imaginary number, and S stands for the sine. Okay, because the fact that it is actually R cos theta plus I sine theta like this, so then that's a shortcut form. Okay, however, I am not really I don't actually like to use this type of notation, okay, because somehow I'm not familiar with this one, okay, because I have not encountered at least any of this word or any of this written form in any of mathematical textbook. Okay, so that's why I'm not actually using this. Okay, but if you want to write using this form, go ahead and do it. It's okay. It's not wrong. Okay, it's just that normally I will just write in terms of this. Okay, for polar form of a complex number. Okay, and for the polar form of a complex number, so it is written in the form of r, and then in the bracket you have cosine theta plus I sine theta, in which, all right, in which r is greater equal 0 means r is always positive. Okay, r equals 0 means r is positive, and r can be equal 0, that means it's a point. Okay, and then theta is written, okay, theta is written between 0 and 2 pi, What does it mean? It means that we are using only a positive angle. Okay, so this statement means, all right, angle, all right, is actually written in terms of positive angle. So if let's say you compute, all right, you compute your theta using your tangent inverse, all right, and then suddenly you got negative, okay, negative number from the calculator. So you got to change that into a positive. So instead of going clockwise, you go anti-clockwise, because positive angle refers to anti-clockwise direction. Okay, so this is theta, and this theta is also can be called argument. Okay, argument. All right. So and R is actually also can be called as magnitude. So sometimes you may see, like when you deal with a complex number in polar form, okay, then people or question may say that you find argument and magnitude, or find magnitude and argument. Okay, so you have that word magnitude, argument, magnitude, argument. So magnitude refers to the R, okay, and argument refers to theta. So if question say you find magnitude and argument, or find modulus and argument, sometimes they use magnitude, sometimes you may see certain book they use modulus. So whether it's modulus or magnitude, it's actually is the same thing. Okay. So another name is actually is modulus. So modulus or magnitude means the same thing, which is actually is the R. So if question say, okay, find modulus and argument, that means question is asking you to compute for R and theta. Okay. All right. Okay, any questions so far? Okay, if not, then let's look at some of the questions here. Okay, let's look at some of the question here. Okay, express the following complex numbers in the polar form. So what you are given is actually is a complex number in rectangular form. Okay, in the form of x plus yi. All right. Okay, and then what you need to do is just to convert to polar form. Okay, let's do this. Right, let's say we start with the first one, which is z equals minus 1 minus I. Okay, now if you remember when we did our polar coordinate last week, okay, we find polar coordinates given rectangular coordinates, okay, and vice versa. Okay, given polar coordinates, find rectangular coordinates. Okay, so when we want to convert, okay, between rectangular to polar or polar to rectangular, remember like last week also we said that it is good if you can sketch or plot. Okay, plot your point last week. Okay, plot your coordinate and see where does it lie. Okay, in which quadrant does it lie. Okay, so similarly, this one also the same. Okay, if you want to convert to polar form, all right, and vice versa, actually, all right, it is also good that if you can sketch, all right, you plot your complex number so that you know that in which quadrant your complex number lies. Okay, because then it will tell you the right, okay, theta that you are going to find. Okay, especially like this one, all right, like this case is where question is asking you to find polar form of a complex number. You are given in terms of rectangular, so when you want to find in terms of polar, so there will be theta then. So when there's a theta, okay, we have a formula using tangent inverse, all right, to compute for your theta, for our theta or for our argument. Okay, and remember when it comes to tangent inverse, okay, we always said that, you know, tangent inverse by the definition of the restricted domain, angle from the question, from the calculator, they will give you always either quadrant 1 or quadrant 4. Okay, but when you sketch, all right, when you sketch, okay, then only you can see if it actually lies in quadrant 2 or quadrant 3. Okay, that's when you got to do something about it. You cannot just straight away use angle from calculator. So you got to figure out what is the right angle for at the right location, at the right quadrant. Okay, so that's why, okay, whenever you want to be able to change from rectangular to polar or polar to rectangular, so it is suggested that you identify, okay, your whether your complex number in rectangular or in polar, it actually lies in which quadrant. Okay, so in this case, you got to just quickly sketch. So if you sketch, like just now you sketch, all right, when you sketch this, all right, okay, you can just see that, okay, this is imaginary. So minus 1 minus I, where does it lie? Okay, so that means from the origin, so minus 1 means you go 1 unit to the left, and then you go down 1 unit. So basically, your complex number for minus 1 minus I, okay, this is minus 1 minus I, lies in quadrant 3. So this is actually is a quadrant 3. Okay, so this is quadrant 3. This complex number lies in quadrant 3. So when it lies in quadrant 3, later on, when you want to find your argument, your theta, all right, and remember theta must be written in a positive angle, okay, anti-clockwise direction. That means your theta must be this theta. This is your right theta. Okay, so you are going to give us that theta. All right. Okay, so let's straight away compute. Okay, so we want to find R and theta in order for us to write our polar form of a complex number. So we need R and theta. So again, R, okay, R is actually formula is square root of x squared plus y squared. Okay, so again, this one, okay, minus 1 minus I, all right, you are going to refer it as like your x plus yi. Okay, so x plus yi. So in this case, what is your x? X is here. X is minus 1. What is y? Y is minus 1. So that means you are comparing it with your z equals x plus yi. Okay, so you're referring or you're comparing with your x plus yi. Okay, to get your x and y. So in this case, all right, it will be square root of minus 1 squared plus minus 1 squared. Okay, so you got your square root of 2. Leave it as it is. Leave it in terms of exact value. No need to change to decimal. So this is the R. Okay, whereas for your argument, your theta, all right, it will be tangent inverse, okay, y over x. Okay, so then this is tangent inverse of minus 1 over minus 1, okay, which is actually is positive 1. All right, so when it is tangent inverse of positive 1, all right, if you know straight away, it's actually 45 degrees. But if let's say you are not sure, or well, you can use your calculator. Okay, so if you have a calculator with you, you can compute and find out what is tangent inverse of 1. All right, so you will see that calculator will give you what? Calculator will give you 45 degrees. Okay, so you can check that. So this is actually is quadrant 1 angle. But you know that our complex number here is actually in quadrant 3. And our theta must be angle in quadrant 3. So you cannot use 45 degree, all right? But you must use what? How much is angle in quadrant 3? Anybody? Okay. Theta is what? In quadrant 3? It will be?
225.
Yes, 2 to 5 degrees, which is actually is in quadrant 3. Okay. All right. So therefore, now your polar form of a complex number will be written as, okay, the expression in terms of polar, all right, can be written as R and then cosine theta plus I sine theta. Okay, so now you replace your R, which is square root of 2, cosine theta is 2 to 5 degrees plus I sine 2 to 5 degrees. Okay. So that is okay, plus and then I. Okay. So this is our complex number in polar form. Any question? Do you want to compute this cosine 2 to 5 degrees? Do you want to compute? No need, no need. If question say that you find your complex number in polar form, this is the polar form of a complex number. So you don't need to compute cosine 2 to 5. Don't compute this. Because if you compute this, what will you get? You will get back rectangular form. Okay, if you compute cosine 2 to 5 and sine 2 to 5, you will get back your standard form of a complex number, which is in the form of a rectangular, which is x plus yi. Okay, because cosine 2 to 5, 2 to 5 is actually in third quadrant. Okay, third quadrant, you can use your reference angle. So that means it's 45 degrees, but because it is in quadrant 3, okay, cosine is negative. So it is actually is the same thing, all right? Just to show you, all right? Okay, this one, if you, all right, this is the same as cosine 45 degrees in, but because of in third quadrant, so you have your negative there. Okay, 2 to 5 is in third quadrant, so cosine negative. So negative cosine 45. Okay, plus I sine 2 to 5, same thing, also 45 degree, but third quadrant sine also negative. So that means, okay, that means it will be negative sine 45 degrees. And what is cosine 45? It is 1 over sec 2. Similarly, 1 over sec 2. So sec 2, you can cancel with that. So isn't that you get your minus 1 minus I, which is your, this complex number. Okay, so that means when question asks you for polar form, so you just need to stop until here. Just stop here. Don't compute. Okay, do not proceed and compute, because if you proceed and compute, what you get is actually back to your original, which is in the form of rectangular form, okay, of a complex number. Okay, so in this case, question just asks you for polar form. So then polar form is just this form. Okay, so that form. So this is the polar form of a complex number. Okay, so one thing that I would like to highlight is actually is the importance of, is the importance of sketching. Okay, the importance of sketching. Okay, the importance of sketching your complex number. Okay, your minus 1 minus I. Okay, so why? Because then, all right, you want to be able to actually get the right angle. If you don't sketch and you just straight away compute, especially this part, if you don't sketch and you overlook that your complex number actually lies in quadrant 3, calculator gives you quadrant 1. So if you straight away write here as cosine 45 degrees here, sine 45 degrees, then it's wrong. Okay, so polar form of that complex number is wrong. Okay. Okay, let's do another one. Okay, the next one is for B. Okay, which is 1 plus I. Okay, let's do W equals to 1 plus I. Okay, which quadrant this complex number lies? Anyone?
Quadrant 1.
When
First quadrant.
Yes. Quadrant 1, isn't it? Positive, positive. That is actually quadrant 1. Okay, that means that if you were to sketch, all right, this is real axis and this is imaginary axis. So somewhere in the first quadrant, one unit to the right, one unit go up. So that is your complex number 1 plus I. Okay. So if it is in quadrant 1, you don't have to worry. So your angle theta straight away, all right, you can get it from calculator. And just by looking at this question, basically it's similar to your part A just now, because your x and y is just 1 and 1. So y over x is 1, right? Tangent inverse of 1 is 45 degrees. So this is actually is 45 degrees. But anyway, just straight away compute. For r, it's the same thing. You have your formula here, which is then 1 squared plus 1 squared, which is square root of 2. And then your theta is just tangent inverse, as I mentioned, y over x, which is tangent inverse 1. So you use calculator. Calculator will straight away gives you 45 degrees. Okay, so therefore, in this case, in terms of complex number in polar form, it can be written as square root of 2 cosine 45 degrees plus I sine 45 degrees. Okay, so quadrant 1 is quite straightforward, because angle you can get it from your calculator. Quadrant 4 also straightforward, because calculator will give you quadrant 4 angle. However, quadrant 4 angle from calculator will be in terms of clockwise direction, negative angle. Okay, negative angle. So when you want to conclude for your polar form, you must change to positive angle. Okay, so you must use your anti-clockwise, all right, angle instead of the clockwise angle. That is if your complex number lies in quadrant 4. Okay, can you try, maybe you try C, everyone? Try this. P equals 4I plus 3. Can you try that? And see what sort of polar form of a complex number that you get. P equals 4I plus 3. Okay, you try that quickly. Okay. Okay, what do you get for your R?
5 minutes.
Okay, 5. Okay, what about theta argument?
53.
53. You round to the nearest degree, right?
Yeah.
Okay, all right. Okay, I hope everyone got it the same. Okay, basically you are given in terms of 4I plus 3. So you might want to rewrite if you want, instead, in case you find it rather confusing. All right, so you can just rewrite in the form of x plus yi, so that you know exactly which one is the x, which one is the y. Okay, so x is 3, y is 4. All right, then you know that this is positive, positive, so it lies in quadrant 1. So when it is in quadrant 1, so you don't have to worry much, because then your theta, your argument will definitely gives you, from the calculator will give you the right angle, okay, which is the acute angle in quadrant 1. So then when you compute for your r, so straight away it will be your, all right, 3 squared plus 4 squared. So that will be 20 square root of 25. So that's, it will be 5. And then your theta. So you just straight away use your calculator and compute for tangent inverse 4 over 3. So like your friend mentioned just now, if you round it to the nearest degree, you will get it as 53 degrees. If you want to use decimal, also can. You can say 53.1 or 53.13. All right, degrees is fine. Okay, because it doesn't mention anything on the around the angle, around your argument to the nearest degree, or use two decimal. No, it does. If once it doesn't mention, it's actually, it's up to you. Okay, as long as you write it clearly. And I would like to remind everyone again, whenever you write your angle, okay, your angle, if it is degree, you must make sure that you have this written. Okay, because during your test, I would say the majority, okay, 80% to 90%, when people write your angle, all right, in terms of degree, you don't have this somehow. Okay, so maybe for the test, we are not really that strict, all right, because we do not want to penalize. If we penalize, it's like we penalize so many in your paper. Okay, but during exam, final exam, you have to be very careful. Why? Because for, especially for complex number, later on you would see, all right, there is, after this there's a section on the exponential form. There's actually the notation does matter, because then for exponential form, later on you will see that angle must be in radian. All right, you cannot use degree. So if it is radian, the radian, definitely there's no notation like this. This notation is only for degree. So that means if you don't have this notation, all right, if you don't have that notation, that means that angle is actually is in radian. Okay, so if you just put like 53 without any like circle, that means it's a 53 radian, which is actually is not correct. All right, for this particular question. So again, notation does matter. So please make sure when you write your angle, if it is in degree, you're using degree measure. All right, then you write. Make sure you have this notation. Okay. If you are using radian, okay, then of course you don't have this notation. And for argument here, for polar, you can actually write in terms of degree or radian. Okay, for polar form of a complex number, theta can be written either in radian or in terms of degree. Okay, for polar form. Okay, all right, but later exponential form, it must be in radian only, cannot be in degree. Okay, so back to here. So once you got that one, therefore in this case, straight away it will be your 5 cosine 53 degrees plus I sine 53 degrees. So this is your polar form of a complex number. Okay, all right, maybe I would like to give you actually one more. Can you try, there's one more question here. Just quickly try this. Can you try that one? 8i minus 6. Okay. You got it? What's the R? Anyone?
Ten, madam, 10.
Okay, and what about angle? What about argument? Okay, what about the argument? The angle?
143.
1?
One
1 for
to
3?
seven. One
Ah,
to
Is
seven,
it?
madam.
Okay. 1 to 7 or 1 for 3? What your
Uh,
calculator gives you when you press your tangent inverse 8 over 6 minus 8 over 6
minus minus 53.
minus 53. So
53.
if it is
Yes.
minus 53, then it should be 1 to 7, isn't it?
Yes. Yeah.
Okay, because then you are using angle in second quadrant, which means that again, what you can do for this question, first of all, if you want, write in terms of x plus yi, so that will be quite straightforward. You can see now, you know that your complex number lies in quadrant 2. Okay, so if you plot, okay, if you plot your complex number is actually is in quadrant 2 because you have your x is negative, y is positive. So this is actually is in quadrant, somewhere in quadrant 2. So somewhere in quadrant 2, okay, so you have your from the middle, so you go 6 unit to the left, okay, assuming this is 6 unit to the left, assuming this is 8 units up. So somewhere there, so that is your complex number. So your complex number is actually is in quadrant 2. This is your minus 6 plus 8i. So that means this is the angle. Okay, so you want angle in quadrant 2. So if you use calculator, okay, of course, first you find your r. So it will be your minus 6 square plus 8 square. So basically that one is square root of 10, square root of 100. So you got, this is 10. And then your theta, your argument is tangent inverse minus minus 8 over 6. So if you use calculator, calculator gives you minus 53 degrees, which is actually, this is quadrant 4. Minus 53 is in quadrant 4. Our complex number is in quadrant 2. Okay, so our complex number is in quadrant 2. So what you need to do, all right, you need to just, all right, use your reference angle. Okay, use your reference angle. So that means, all right, this is your reference angle 53 degrees. So then 180 minus 53 degrees, so that will give us 127 degrees. So that means theta is 127 degrees. This is the quadrant 2 angle. So therefore, okay, your W, oh sorry, your P in terms of polar form can be written as, all right, 10 and then cosine 127 degrees plus I sine 127 degrees. Okay, all right. Okay, any question? Any question? Can you all follow? All right. It's going to be like 2 minutes to 3. So I think maybe I'll stop here first. We'll take a break for 5 minutes. Then after this, I will continue with the next section, which is exponential forms of a complex number. Okay. All right. So we take a break for 5 minutes. Oh, someone's screen is frozen, is it? Adelina, yours? Maybe you try to exit and then try enter again. Okay, for those who have a problem with the screen, all right, their screen is not like you don't see that my slide moving, all right. So perhaps you try to exit and then you try to join again. See how?
Madam,
Yes.
about the questions for finding the theta, madam.
Okay.
Is it the 8 positive or negative, madam?
Positive. Oh, okay. You see the way I'm writing like this. Sorry, this one. This is actually
Yes.
eight is positive, but because 6 is negative, so perhaps it doesn't matter, isn't it? So it is
Oh, okay,
still
okay.
it is still negative. It is still negative. Okay.
Oh, okay,
Yeah,
okay.
of
Okay,
course,
madam.
by right I should actually write minus like this, but actually it's actually is the same thing. Okay.
Oh, okay,
So
madam.
that means because that means I can write like this, or I can write just straight away minus 8/6. But still it's a negative number. Okay. All right.
Okay, madam. Okay, madam. Thank you, madam.
All right. Okay. Welcome. No, Adelina, you want me to go up a bit? Where? Here? See? Or you want this up? Which one? Okay, this one. Okay, hold on. Let me just pause my. Okay, let's continue. Okay, everyone, let's continue with what we call now exponential form of a complex number. Okay, so I hope everyone is ready. Okay, basically there is another form which is what we call exponential form. But this one is actually is quite straightforward. All right. There is another name of it which they call it Euler's formula. Euler or Euler. This is just after mathematician names. Okay. And it states that e power I theta equals to cosine theta plus I sine theta, and then it follows that blah blah blah. This is just for the exponential, or you have like power. Okay, but what we want actually, the form is actually is this one. This is what we want, that form. Okay, this form. Okay, so for exponential form of a complex number is in the form of r times e power I theta, where r is the same thing because when you have the r theta, it's the same thing. Okay, r is actually is a modulus. Okay, r is a modulus. So this is actually is the theta is the argument. Okay, so this is what we call the exponential form of a complex number. But one thing that you must note, this is the one I mentioned just now. So theta or your argument theta here must be in radians, not degree measure. So that means if question asks you for exponential form, okay, if question so if question asks you for exponential form of a complex number, so you must make sure that when you use your calculator is in radian, or perhaps if it's a simple angle where you use your degree mode calculator, and then you know how to change to radian. Like for example, you use your degree and then you got like for example 45 degrees. Then 45 degrees, you know, it's just pi over 4. So then use your pi over 4 also can. But the most important is when you write, okay, when you write exponential form, you must write using radian only for argument. Okay, let's straight away look at the example. Okay, so that you can actually understand this clearly. All right. Okay, this is okay, Adlina.
Here, madam.
Okay, you got a question to ask?
No.
No. Okay.
I'm still having trouble with the screen.
Oh, okay. So means that your screen doesn't move. It's
Yeah.
stuck.
I tried to use the web instead of the apps.
But still the same problem.
I think.
Okay. All right. Okay. All right. Okay. Okay. Let's look at this question now. So you are given a rectangular form of a complex number, and question asks you to write in exponential form. Now, because exponential form still require the r and theta, means that still require a parameter for polar. Actually, exponential form, all right, this expression, the r and theta are the parameter for polar. Okay, so in this case, if you want to compute for r and theta, still like previous, given this complex number form, okay, you must identify that this complex number lies in which quadrant, so that you will get the right angle. Okay, so that you can get the right angle. Okay, so let's do the first one. Okay, let's do the first one. For z equals to 1 minus 3i. Okay, so this one basically is in which quadrant? 1 minus 3 is in which quadrant? This is quadrant what? Quadrant 4, isn't it? Okay, so it's a quadrant 4. All right, it's a quadrant 4. Okay, so that means that later on your theta also must be in quadrant 4. Okay, in this case also definitely your theta, if you use calculator will give you quadrant 4 angle. Okay, so straight away we do this. Compute for your r, which is your square root of 1 squared plus minus 3. Okay, so this is your square root of 4, so which is you'll get 2, that is your r. And theta is tangent inverse of y over x. So y is minus 3, x is 1, which is your tangent inverse 3. Okay, now if you use your calculator gives you what angle? Anyone? Calculator gives you what angle? Minus 60. Okay, calculator gives you minus 60 degrees, all right, which is in quadrant 4. This is actually is quadrant 4. Okay, it's just that quadrant 4 like this. Okay, minus 60 like that. Okay, so our argument must be positive angle, which is in this case, which is 300 degrees. All right, so that means it is the same as 300 degrees. Okay, however, remember just now here, theta must be in radians. not degree measure. So that means, all right, either from the very beginning, okay, from the very beginning, when you compute this, you just straight away, when you use your calculator, straight away you change your mode. Okay, you change your mode to radian mode, okay, in your calculator. So up to you actually. Either you want to straight away from the beginning change the mode into radian and then compute, or you can compute like this on, that's like this one in terms of degree. All right. However, after that you change 300 degrees into radian. Okay. And in terms of radian, you can use exact value of the radian. If you use the exact value, that means, all right, what you need to do, okay, you got to, all right, multiply by pi over 180. Remember how do we convert from radian to degree to radian? Okay, so if you want to use exact value, all right, you multiply your 300 degrees by pi over 180 degrees. If you do that, you will get this as 5 pi over 3 or 5 over 3 pi, or you can also use in terms of decimal. Give us in terms of decimal number in terms of radian. Also can. So if it is decimal number, okay, then the radian for 5 pi over 3 is actually 5.23 radian. Okay, 5.23 radian. So the most important is when you write your final answer in terms of exponential form. So exponential form is in the form of r e power I theta. Okay, but because theta is only a number expression. This is just a value expression. You can write your I behind. Okay, so you can just write in terms of r is 2, e power, okay, you can write as 5 pi over 3 I, or you can write it as 2e power 5.23 I. You can write like that. Okay, maybe I'll just write here 2e power 5.23 I. So you can also write like this. Okay, so this is our exponential form. All right. Okay. Can you try this? Can you try this part? B. W equals minus I. Try that one. W equals minus I. Okay, compute your R and theta and then write in the form of R e power theta I. Okay, got it? What is the R and what is theta? What is the modulus and argument? Anyone?
Square root -1, ma'am.
R is what?
Square root -1.
Not quite right, because R is a distance, so you cannot get negative
Oh,
number, or you cannot get imaginary number. It has to be a real number because R is positive.
mm,
R is 1, madam.
Yes, it's a positive 1. That is R. Okay. What about theta?
-45.
Nope.
-45.
No.
Negative 45. Negative.
Okay. No. Okay.
0.
Minus I. Sorry. Say again. You should not guess. You should actually compute. This is not guessing. Okay. By the way, R is just, okay, in this case, X is 0, right? So R is actually is 0 squared. Basically, it's like this, right? Which is square root of 1, which is 1. That is R just now. So you should not get -1, Should not get square root -1. R is always positive because it's a distance, it's a magnitude. So it should be a positive number. Okay. If you use calculator for tangent inverse of, okay, y over x, right? So basically it's -1/0, right? So a number over 0 is what? 1/0 is undefined. Okay, of course you cannot. Okay, what calculator gives you? If you use calculator, let me check
Math
also.
error.
Math error, let me try my calculator. Tangent inverse. I just want to see tangent inverse, and then -1/0. Okay. Yes, math error. Why math error? Because that is the place where tangent has asymptote line. So that's why it's undefined. Okay. But anyway, it doesn't mean that you cannot find out about your theta. Why? Because you can always sketch. How do we sketch that minus I? Where is our minus I? On our Argand diagram. Okay. If we sketch on our Argand diagram, all right, we don't have a real part. So what we have is only imaginary part, which is our -1 So that means from the origin, from the middle, we go down only 1 unit, right? So basically this part, that is your minus I. So if that is your minus I, what is this angle?
270.
Sorry?
270.
Yes, it's 270. Okay, angle is actually is 270 degrees. So in terms of radian, all right, in terms of radian, that is what? 3 pi over 2, isn't it? 3 pi over 2 is your 270 degrees. Either you say 3 pi over 2 or you can use calculator. All right, that 3 pi over 2 in terms of decimal is 4.71. So it doesn't matter which one you write as long as it is in radian. So basically, this is actually is your 270 degrees. Okay, so you got this from the sketch. So remember, it is actually logic. That's why first thing you got to find out by sketching. Because when you sketch, all right, when you plot, you can see exactly, all right, in terms of it, especially in terms of its angle, in terms of its argument. Okay, so therefore, W equals to, okay, in the form of exponential, RE power I theta or theta I. So R is 1. So that means straight away it's just E to power. Okay, either I write as 3 pi over 2I, or as I said, if you use calculator in terms of decimal also can. It is approximately 4.71 radian. So 4.71 I. So basically, the exponential form is just similar to polar. You just need to find out r and theta. The difference is only the form. Okay, the difference is only the form. Okay, understood, everyone? All right. Okay. Okay. Then the next one. Okay, because we have in terms of polar form of a complex number, so therefore you also have a theorem, all right, on the what we call product and quotient. That means this is a theorem to actually compute a multiplication or and division of two complex number but in polar form. So again, back to your polar form of a complex number. Polar form is in the form of r times cosine theta plus I sine theta. That's the form. So if you are given like two polar form of a complex number, if question asks you to multiply or asks you to divide, this is actually is one theorem which gives you a quite straightforward, all right, quite straightforward method to multiply as well as divide two complex number in polar form. So if you look at the formula, let's say assuming that you have one polar form is in this form, okay, the subscript one means is the first complex number given, and then another complex number given in polar form with the subscript 2, okay. So if question asks you for a multiplication or a product, okay, multiply z1 times z2, okay, if you observe this theorem, basically in terms of magnitude r modulus, what you need to do, you just multiply the two modulus. Just multiply r1 here with r2 here. Multiply. Okay. And then in terms of argument, what you need to do, if it's a product, you just add theta 1 here, you add with theta 2. Okay. So that means modulus you multiply, argument you add. Okay. You sum the argument. Okay. Division, however, if it is Z1 divided by Z2, okay, in terms of modulus, you divide R1 divided by R2. In terms of argument, you subtract. Okay, theta 1 minus theta 2. Okay, so again, for a quotient, in terms of modulus, you divide. In terms of argument, you subtract. So in a way, this theorem is actually gives you a very straightforward method to multiply and divide for two complex number in polar form. Okay, is in polar form. If you are given just in rectangular form, all right, rectangular form, you remember if it's a rectangular form, let's say you have last time 1 minus 3i times 2 plus 2i multiply. Last time we said that if it's a rectangular, you just expand like that. If it's a multiplication, if you ask to divide, then last time we said what you need to do for division, you multiply by conjugate. All right, conjugate of the denominator. Then only you simplify and get the answer in the form of a plus bi. So if it's a rectangular, you do like this. Okay, you do like this. But if question are given in terms of polar form, then you have this theorem, these two theorem. Okay, all right. Okay, let's look at example. Okay, maybe I'll write down the. Okay, maybe I'll write down the question. Okay. This is. Okay, find Z1 times Z2, okay, given the following complex numbers. Okay, so Z1 is given as 3 cosine 35 degrees plus I sine 35 degrees, and Z2 is given as 2 cosine 10 degrees plus I sine 10 degrees. All right. Okay. So if you look at the formula for a product, you have this, which means, all right, modulus, you multiply, argument, you add, okay, or you sum the two arguments. All right, so the answer would be for Z1 times Z2, because both are given in terms of a polar form. So that means 3 times 2, okay, and then cosine, okay, 35 plus 10. Okay, I'll just write step by step. Sine 35 plus 10 degrees, which means the answer will be 6 cosine 45 degrees plus I sine 45 degrees. That's the answer. Okay. All right. Okay, maybe I'll give you another one. Okay, now Z1 is given as 4 cosine 80 degrees plus I sine 80 degrees, and Z2 equals 2 cosine 145 plus I sine 145 degrees. Okay, what's the answer for Z1 times Z2?
It is 8
8,
cosine 225 degrees
okay, plus
plus I sine
225.
200. Yeah.
Okay, all right, correct. Thank you.
Okay, madam.
Okay, all right. Okay, maybe I'll give you another one. Do I have, let me see. Oh, okay. Another one is actually is a different question. Okay, let's look at this is actually is first example. Okay, let's look at second example. Okay, this time you are given, this is your Z1, which is 4 plus 3i. Okay, so you are given now in rectangular form. And Z2 is 1 minus I. So find Z1 times Z2 in polar form of a complex number. Okay. All right, let's look at this question now. Okay, are you all ready? Okay, for this question, now you are given two complex number in rectangular form. Z1 equals to 4 plus 3i and Z2 equals to 1 minus I. Okay, so you are to find a product Z1 times Z2, but question wants you to find it in polar form of a complex number, which means final answer is in polar form. So for this question, actually, there are two ways to approach. One is you straight away change this to polar form and change this Z2 also in polar form. Then only when you multiply these two, you use this concept just now, where you, for the modulus you multiply, and then for the argument you plus, you sum, okay, or you add two arguments. That is one way. Another way of doing, you can actually multiply straight away, rectangular form and rectangular form. So you got, just now remember, if it's a rectangular form, when you multiply, you expand. Okay, so you expand the terms. So the product is in rectangular form. So once the product is in rectangular form, then only that product you change to polar form, because final answer must be in polar form. So it's actually is either way. All right. So it's actually it's up to you. Okay. So you have that approach. Okay. Now let's say I just want to use one method. What I'm going to do. Okay. Since we are actually using polar form, so might as well I'll straight away change this to polar form. I will change this to polar form, and then only I use the theorem just now to find the product. So which means, okay, so first for my Z1, I am going to find my R and theta, then I'll write it in polar form of a complex number for Z1. Okay, so first I know that 4 plus 3i, this one is because it's positive, this is in quadrant, this is in quadrant 1. Okay, so then later I know that my angle has to be acute angle in quadrant 1. Okay, and quadrant 1, calculator will definitely give us that angle. Okay, so compute for the R straight away. Okay, compute for R. All right, so this is my 16 plus 9, so 25. So then I'll get my 5 for R. And then my theta, okay, I have to use calculator. This one, tangent inverse, 3 over 4. So if I'm using that, where is my calculator? Okay. So tangent inverse. Okay, so this one is roughly, I will get, okay, maybe I'm using decimal, so 36.87 degrees. Okay, so therefore my Z1 in terms of polar can be written as 5 and then cosine 36.87 degrees plus I sine 36.87 degrees. That is my Z1 in polar form. Okay, then compute for my Z2 now. Okay, so Z2 is given as 1 minus I. So this one, I know that this one is actually is in quadrant 4. So when it is in quadrant 4, also I will get from calculator. It's just that calculator will give me in terms of a clockwise direction, the negative angle. So I got to change into positive angle. Okay, when I write my polar form for my Z2. Okay, but again, R is square root of 1 squared plus minus 1 squared. So I get my square root of 2. Okay, 1 plus 1. Theta is tangent inverse minus 1 over 1. Okay, so this is where, all right, I know that This is tangent inverse of -1. Calculator will give me minus 45 degrees. Okay, from calculator. So I need to change to 315 degrees in quadrant 4. Okay, so both actually is in quadrant 4. So it's alright, it's in quadrant 4. It's just that calculator gives us in terms of the negative angle, which is in the clockwise direction. So what we want is the anti-clockwise, which is a positive angle. So therefore, my Z2 is Z2 cosine 315, okay, plus I sine 315. So this is my Z2 in polar form. So then only now, alright, if I want to find my Z1 times Z2 using theorem, okay, using theorem, okay, then only, okay, when I multiply 5 times Z2, just leave it as it is. Because leave it as exact value, okay? No need to use decimal. Okay, however, for argument, we are going to add 36.87 degrees plus 315, and then plus I sine also 36.87 degrees plus 315. Okay, so you just need to add. Okay, so if you add that, you'll get 5 sec 2 times cosine 351.87 degrees plus I sine 351.87. Oh, not enough space to write. Okay, maybe I'll just write down. Okay, okay, plus I sine 351.87 degrees. Okay. All right. Okay. Any questions so far? This is a product. Okay, now next example, I'm going to give you in terms of quotient. Okay, in terms of quotient. Because back to the theorem just now. Okay. Now you are going to apply this for the quotient. So for the quotient, we are going to divide modulus, both modulus. And then as far as the argument is concerned, we are going to subtract. Okay. So according to the theorem, it has to be R1 divided by R2, theta 1 minus theta 2. So you cannot do the other way around. So depending on which complex number the first one is given. So that will be the first one. Okay. So if the second one given, that is the second one. That is subscript 2. Okay. According to this theorem. So you cannot just simply divide. Okay. All right. But if it's a product, it's actually does not matter because it will be the same thing because this is a multiplication, this is addition. So either you 3 times 2, 2 times 3 is the same. Okay, but here if it is 3 divided by 2 and 2 divided by 3, they are not the same. So you have to be very careful. All right, okay. Okay, let's look at example for the quotient. Okay, this time Z1 divided by Z2. Okay, given the following complex number in polar form. Okay, Z1 is given as 6 cosine 125 degrees plus I sine 125 degrees, and Z2 is 3 cosine 65 degrees plus I sine 65 degrees. Okay. All right. Okay. Then, according to the formula, according to the theorem, all right, if you divide Z1 divided by Z2, so it will be 6 divided by 3. That is for the modulus. Whereas for the argument, it will be 125 degrees minus 65 degrees. Okay, plus I sine 125 degrees minus 65 degrees. Okay, which means, okay, the answer would be, right, 2 cosine 60 degrees plus I sine 60 degrees. Okay, all right. Okay, now, any question for this question here? Any question? Okay. Okay, you try this one for the second question. Cosine 5 pi over 12 plus I sine 5 pi over 12, and Z2 is given as 3 cosine pi over 12 plus I sine pi over 12. Okay, you try that. All right. Okay, what's the answer?
3.
What's the answer for Z1 divided by Z2? You got what? 3.
3. Cos
Then
60.
cosine.
60.
Okay, you are given in terms of radian here. Can you use radian?
Oh, okay.
You are given a pi radian. What is that? 60 pi over 3, right? Okay. Plus I sine pi over 3. Okay. Okay, everyone. Okay.
Okay, madam.
All right, okay. Then the other example. Okay, I'm using the same question just now. Yeah, the one that is the given Z1 just now in terms of rectangular, the 4 plus 3i, and Z2 just now. It's a similar question, but now we want to find the product as the quotient. Okay, so find Z1 divided by Z2. Can you try this? Okay, you don't need to compute again R theta. Just use the same answer like just now. Okay, the previous, this is the same in under the just now the product. The same example. This example. This one. Okay, so I'm using the same one. So it's just that now we want to find quotient. So you use the same Z1 and Z2 in polar form. So just use back and then just find out in terms of its quotient. Can you try? Try now. Okay, you got the answer?
Is it 8, madam?
Say again. What's your,
8.
You got your Z. That means that Z1 divided by Z2. What do you get? 8.
8.
Okay, and then?
No, madam. It is 4.
Okay, just refer back just now. Z1 just now from earlier is our 5, right? If we look at the previous one just now, it's 5 cosine 36.87 degrees plus I sine 36.87, right? And then our Z2, okay, our Z2 is Z2, isn't it? This one, okay, that one. Z2 cosine 315. Cosine 315, this is from previous, plus I sine 315. Okay, so now you just need to divide Z1 divided by Z2. Okay, it will be modulus, we divide, so 5 divided by Z2. Alright, okay, in terms of argument, it will be cosine, okay, and then you have your 36.87 degrees minus 315, okay, and then plus I sine also 36.87 minus 315. Okay, 5 divided by Z2, you just leave it. Or if you want to rationalize, can also. You can rationalize in terms of like 5 sub 2 over 2 like this, can. So either one. Even if you leave it as like this also, it's fine. It is acceptable. Okay, or you want to rationalize your denominator, you want to write like this one also can. Okay, so modulus, all right, leave it as it is in terms of exact value. No need to compute in terms of decimal. However, for argument, okay, so 36.87, so you subtract by 315. Okay, you get this, minus 278.13 degrees. Okay, right first, plus I sine minus 278.13. This one is a direct subtraction. However, okay, remember we said that we must use argument in terms of its positive angle. So this minus basically you are going this direction. You are going clockwise direction, going this way, negative, isn't it? So negative 278. Okay, so basically negative 278 is where? Where does it stop? Somewhere in
Quadrant
quadrant 1.
4.
Quadrant 1. Quadrant 1.
Quadrant 1.
Yes.
Quadrant 1, right? Okay, quadrant 1 going clockwise direction. Okay, all right, so somewhere here. All right, that is our minus, okay, our minus 278.13 degrees, isn't it? Okay, so that means that you just need this angle here, this angle. Okay, so that angle is what? It will be 81.87. That means you just minus 278.13 degrees plus with 360, isn't it? So your final answer, you use that 81.87 is a positive angle. Okay, because argument must be in terms of positive angle. So your final answer, which is 5 sub 2 over 2, or you can say just now like 5 over sub 2, then cosine, okay, 81.87 degrees plus I sine 81.87 degrees. Okay, all right. Any questions so far? Okay, so basically product and quotient, it can be also straightforward. Basically, it's just using theorem. Using theorem, make sure you know the procedure, okay, the method. If it's a quotient, you divide modulus, and then argument, you subtract. If it is a product, a multiplication, modulus, you multiply, and then argument, you add. Okay, you just sum up the two arguments. So that is the product and quotient, okay, for polar form of a complex number. And then just now the exponential form, basically just use the form in terms of e power r times e power I theta. So that is exponential form of a complex number, where you still need to find out the r and theta accordingly. Okay, and then you have also earlier part is the where we introduce you the polar form itself, okay, of a complex number. Okay, I think that I am going to just stop here for today's session. We will still have one last section, which is about De Morgan's theorem, a theorem whereby gives you ways or method to, for example, find for example, find you're given one complex number, minus 2 plus 3i power 5, something like that. Okay, or given you in terms of polar form, can also. All right, fine. 2 cosine, maybe cosine what, 45 degrees plus I sine 45 degrees, the whole thing power 10, something like that. So you have like complex number to power. You have a power. All right, how do you actually find complex number to power. If it is power 2 here, it is still okay, you expand, all right? But when it is at power 4, 5, 6, 10, 11, and so on, so you cannot be like expanding terms already, because then it is like too tedious already. It's impossible to do that. So there is a theorem which gives you like a very straightforward method, okay, to take care of this power, okay, by what they call De Moivre's theorem. Okay, so that is just a small part which I am going to just perhaps talk about it next week, okay? And next week also I will start also with the last chapter, which is chapter 5, because basically this chapter ends until that De Moivre's theorem. Okay, all right, so it's nearly 4 o'clock. I think I'll stop here. Any questions so far? Can you all follow today's session? Do you all understand about polar form of a complex number? Okay,
Yes, madam.
all right. Okay, no question? Understood, eh? All right, so make sure you just prepare for tutorials, all right, for this Thursday session. All right, look at some of the questions for complex number, especially the earlier part. Okay, maybe like in section 1, section 2, okay, the earlier part. Okay, maybe we will take a look at those questions. Okay, all right. Okay, I think I'll stop here.
Okay, madam.
Okay,
All
madam.
right. Okay, if there's no question, then we'll meet you again on Thursday, inshallah. All right.
Thank you, madam.
Thank you,
Okay,
madam.
then.
Assalamualaikum.
Okay, welcome.
Thank you, madam.
Thank you, madam.
Thank you, madam.
Thank you for your
Assalamualaikum, madam.
Thank you, madam.